Hello viewers, you're welcome back to the fourth section. In this section, we want to consider odd and even functions. There are some functions that we can refer to them as being odd, while we can refer to some as being even. So in this video, we need to consider the two because we need a concept whenever we are dealing with Fourier series. So let's consider the first things. When do we say a function f of s is even? We always start with negative value of x, and by the time we put negative value of x inside the function and we get positive f of x, then we can say that the function is indeed even. And for the other case, which is odd, likewise we start with negative x. So we put negative x inside the f of x, and if we get a minus f of x, then we can conclude that the function is odd. But before we proceed, let's first of all look at something. When we had two functions together that are even, function f of s is even, function g of s is even, when we had the two together, what are we going to get? Even function. And likewise, if we subtract one even function from another even function, what we are going to get is an even function. And in terms of product, by the time we multiply two functions that are even, I'm talking about the product of two even functions, what we are going to get is an even function. So we're going to consider this in a very broad way later. But now, let's consider two things very important. That's equation 4.1. Now, f of x is an even function. I want to integrate it over the interval of minus a to a. The point is that we can change this expression to give us integral minus a to 0 f of x dx plus integral 0 to a f of x dx. What I'm trying to say is that we are trying to partition the integral from minus a to a by considering the middle point, which is s equals to 0. So, since f of x is even, then integral from minus a to 0 of f of x dx is the same thing as is 0 to a f of x dx. So, if that is the case, then we can now see that provided f of x is even, then we are going to get 2 of it over the interval of 0 to a. What I've just explained recently might not be enough. Let's look at the graph of an even function. If you look at the graph of an even function here, you will see that from minus a to a, from minus a to 0, and from 0 to a, they look alike, but symmetrical. But here, the symmetrical is about the y-axis. So which means that if you move from a to 0, from 0 to a, they are the same thing, but from different sides. What we're not trying to say is that if you integrate minus a to a, it is the same thing as you integrate 0 to a f of x dx twice. That is how we obtain 4.1. What about the case of odd? In the case of odd, provided f of x is an odd function, what we can see here is that minus a to 0 f of x dx is the same thing as minus 0 to a f of x dx. So from here we can see now that whenever we want to integrate an odd function from minus a to a, what we are going to get is 0, provided f of x is an odd function. Provided f of x is an odd function, if you integrate it from minus a to f of x dx, what we're going to get is 0. The same thing applicable to sinusoidal functions. Sinusoidal periodic functions. If you integrate them from minus pi to pi, f of x dx, provided f of x is an odd function, what you are going to get is 0. Please take note of that. But meanwhile, if you integrate an even function from minus a to a, what you are going to get is 2 of integral 0 to a f of x dx. So we are going to stop at this stage, but we have tutorial questions 4.1, which we solved already. It's just trying to tell us about two functions that are even, which is x squared. X squared is an even function. Even cos x is an even function. And likewise, x raised to power 3 is an odd function, and sin x is also an odd function. So if you look at this very well, you always notice that even function is symmetrical about the y-axis, while the odd function is symmetrical about the
We share.
Tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.